Hello, everyone. This is Bob here. I'm recording the lecture 26, a modified corrected version. And this is on the example of calculating development length of the bars, okay? So to calculate development length of the bars, let's take a look at the example, right? So for the example, I have a rectangular section right here and have a width of 12 inches. So I'm going to change the marker to be this one so you can see it better. So I have a 12 inch of width. I have 20 inch of depth. I have three number 8 bars, okay? F prime C concrete 4 KSI, Fy 60 KSI yield strength of the bar. I have number 4 stirrups at a spacing of 8 inch. I have 1.5 inch of a concrete cover, and this is from the edge to the stirrups. Okay, so this example, right? First thing I notice is that all my bars on the top, three number 8 on the top, okay, and I definitely have more than 12 inch of a concrete cover underneath it. So I know that I have a bar factor of psi s equal to psi t equal to 1.3 immediately. All right, so I'm going to walk you through from two approaches. One is a simplified approach. So from last we talked about it, we're going to use a table here. So the left column, I have spacing and cover. I have number 6 bar or smaller. Number 7 bars or bigger. And the equation to be used is this one right here because I have a clear spacing that is bigger than the bar diameter, okay? Bigger than the bar diameter, basically 1.5 inch is bigger than 1 inch, number 8 bars, okay? So look at the equation here. I'm going to use Fy psi t psi e divided by 20 lambda square root of prime c multiplied by dB. So knowing that I have top bars position, so psi t equal to 1.3. I have uncoded bar, so psi e is coding factor 1.0. Plug in this equation here, yield strength is 60,000 psi. Psi t is 1.3. Bar factor, coding factor is 1.0. I have 20 and lambda equal to 1 because normal weight concrete. I have 4,000 psi, which is the concrete compressive strength, multiplied by the bar size, dB, because it's a number 8, so I have 1 inch. So plugging these numbers, I calculated the calculated development length. In this case, is LD equal to 61.7 inches. Okay, so compare with the conventional approach, right? So I have LD equal to 3 over 40 Fy divided by lambda square root of prime C. Psi t is the top bar position, psi is coding factor, psi s is the bar size factor, and divided by CB, which is the concrete cover factor. We'll talk about this. And KTR is confinement factors, basically stirrups, and dB, which is the bar size. The whole thing will be multiplied by dB, which is the bar size. Okay, so talk about the CB plus KTR divided by dB. We know that has to be limited to be smaller than 2.5. So just have to double check on that, right? In terms of KTR, which is the confinement factor due to stirrups, we have the equation of 40 multiplied by ATR, which is the cross-section area of the stirrups, divided by S. S is the spacing between stirrups. So spacing of stirrups, okay? And N is number of bars being developed here. Number of bars being developed here. So take a look at the cross section here. I have three number 8 bars going this way. I have stirrups spacing at 8 inches, so S equal to 8. I have 3 bars that are being developed, so N equal to 3. I have number 4 of stirrups, and the cross section area for the stirrups is 2 legs, 2 legs. Each leg I have 0.2 inch square, so I total have 0.4 inch square of transverse reinforcement. Okay, so psi t is the top bar factor 1.3. We know that. Psi e is the coding factor, which is 1.0. Psi s is the bar size factor, which is 1.0. And now I have to decide my concrete cover CB. Okay, now we know that concrete cover CB is the lower value between the corner bar spacing, okay, spacing from the corner, and half of the spacing between bars, half of the spacing between bars. So let's calculate. So C1 is the corner bar. So I have 1.5 inch of clear cover plus number 4 stirrups plus half of the bar diameters. I get 2.5 inch, okay. Now C2 is the distance between bars. And mind you that we made a small mistake in the last lecture's notes, so I'll make a correction here. Okay, so to calculate the spacing between bars, okay, so this is C2. I have the width 12 inch minus the 2 clear cover, which is 1.5 multiplied by 2, then minus the 2 stirrups, okay, this is 2 stirrups, and then minus the half of dB from this bar, half a dB from this bar and dB from the central bar. So half dB multiplied by 4 divided by 2. This is the spacing between bars, and I got 3 inches. Got 3 inches. But coming back to see the equation, CB equals to the minimum of C1 half C2. Okay, half C2 is 1.4 actually, 1.5 actually, right? So I have 2.5, 1.5. Lower number is CB equals to 1.5 inch. Okay, so this is CB. Now I can calculate my KTR. So KTR equal to 40 ATR divided by S and multiplied by C and sorry N. Okay, so N is number of bar developed here. So bring the equation. So this is 40 and ATR equal to 0.4 inch squared, which is calculated, and divided by 8 inch of serial spacing multiplied by 3 number of bars being developed. That is 0.667. This is KTR. Okay, now with KTR obtained, I can calculate CB plus KTR divided by dB, and this gives me a 1.5 inch of concrete cover plus 0.667 of KTR divided by a 1.0 inch of bar size at bar diameter. I get 2.167 inch. Okay, 2.167. Okay, so this actually no unit. This is a confinement factor. Just to double check, this is indeed smaller than 2.5. So we'll go ahead and use this number. Okay, we'll go ahead and use this number. Okay, so now looking back at the equation, right? So LD, which is development length calculated using the traditional approach, the equal to 3 over 40 multiplied by Fy divided by lambda square root of F prime C multiplied by psi T, psi E, psi S, okay, divided by CB plus KTR divided by dB, and then whole thing multiplied by dB. So now I can plug the numbers, right? So bring this number inside 3 over 40, and Fy is 60 KSI, so 60,000 PSI. Lambda equal to 1.0 square root of 4,000 PSI, okay? And then psi T equal to 1.3, psi E equal to 1.0, psi S equal to 1.0, divided by this fellow here was calculated as 2.167, and whole thing multiplied by 1.0 inch of bar diameter. I got a 43 inch of development length. Okay, so I just want you to compare the LD development length calculated using the conventional approach. Okay, now compare with previously calculated 61.7 inch of simplified approach. You find that simplified approach is more conservative. Simplified approach is more conservative, means it's safer, okay? So normally if the category falls into the requirement of simplified approach, we will use simplified approach, okay? All right, so this is the remake of the short lecture we supposed to have on last Thursday. And I'm just gonna stop sharing here and make a quick announcement. First of all, our exam is gonna be in terms electronic version, okay? It's gonna be in terms electronic version, okay? And we'll have it online similarly as we done on the exam 2. Okay, and I will post the exam 2's grades, and you'll see it quickly soon. And you compare your grades between exam 1 and exam 2 and make a justification in your learning style. Okay, and we'll talk about that tomorrow. Now about homework number 10, I will repost homework number 10 with revised questions, and you will have till this Thursday as a new deadline, and I'll post the deadline as well. Okay, so beyond that, we can discuss more on Monday. And this is just a short remake. Okay, now I hope you had a great Thanksgiving break, and we'll talk about it tomorrow morning. All right, thank you very much, and talk to you soon. Bye now.